Pre-lesson, pre-calculus, 3-1, day 1. The title of this is Fundamental Identities. Identities, as you can see, are just another fancy way of saying equations that are true. So we're going to have to be familiar with these, but I want to start you off by just saying these are not going to be required of you to have memorized. So you can take that burden off your shoulders. A couple of these should somehow sink into your head, and they just stick with you. But the majority of this, these are going to be given to you for your quizzes and your tests, so you don't have to worry about that too much. Now, the goal of all of this crazy looking stuff is to simplify. So again, this is pre-calculus, which means it's preparation for calculus. And you're going to be really expected to be able to simplify things so that when you have to take what's called a derivative, life will be easy, not hard, and things will just go better for you. So that's the goal of this whole unit. Now, I'm going to start out with example 1 here. If you leave your answer 22/44, those brazen math teachers they know that you're supposed to reduce your answers always, they might mark it wrong. If they have half a soul, they go minus a half. If they're total softies, they won't even mention anything. But you should know that you should be able to reduce that to 1/2. And there's your safety net. There's no way a math teacher or professor could mark you off for doing that, because you wrote your answer in the most reduced form. Now, this is simple compared to what we're going to be doing, but that's generally what you're going to be doing. You're going to be manipulating these equations so that you can simplify these expressions. And there's a purpose for it. But notice this is 3-1, day 1. 3-1, day 2, we'll have more of the purpose. And then, as we continue on, you'll see the why behind the ability to simplify things. All right. Well, let's actually dive into this. So 2/3 times 9. I like to teach my students this. So here we go. My right hand is a fraction. My left hand is a fraction. When I multiply fractions, I cross-reduce, then I swoosh. I cross-reduce, then I swoosh. That skill is going to be very helpful in the stuff coming up. So let's practice it. So 3 goes into 3 once, 3 goes into 9 3 times. See, I just cross-reduced. Swoosh means multiply straight across, so I get 6. All right. That sort of thing is going to happen in trigonometric form, where you're kind of like this, and you're like, oh, hey, I can just cross those out, and my answer is sine. Now, some of you that just have that need of like, well, what did I find? Well, that's not really the goal. The goal is just to simplify today. So you didn't find anything. You just simplified something, just like you did up here. But then in this situation, you have what your brain thinks is an answer. Here, you have a representation of an answer. You're going to have to be okay with that. Now, there are a few, they're called cofunction identities at the top half of page 79. And you see a bunch of pi over 2s, pi over 2s, pi over 2s all over those places. So for you in here, I don't know if the camera's going to zoom in on that, but I'm just going to give you a general idea of what they're talking about. No, we're not going to do more graphing, but the graphing kind of helps you understand these formulas. For example, notice I got y equals sine is right here. Y equals cosine is the red one. And if you notice, if I just take this red one and I move it over 90 degrees this way, you will notice that this spot will go to this spot, and then literally they will be the same line. Or if I take the sine curve and I back it up 90 or move it forward 90, it's going to be the same curve. This is where these little equations come from. This is simply saying sine is cosine moved 90 degrees, or cosine is sine moved 90 degrees. That's what this is saying. Now, Are we actually going to be doing graphing? No. I just wanted to give you a little bit of an idea where these formulas come from. And as you can see, there are a whole bunch of different ones that say cotangent is tangent slid back 90 degrees, secant is cosecant slid back 90 degrees, and on and on and on. Now, we didn't even take the time to graph tangent, cotangent, secant, cosecant. Shame on us. But again, in the trimester format, we just don't have time for that any longer. But generally speaking, that's where these come from. Now, what about these Pythagorean identities? Well, if I had more time, I'd go into great detail about how these actually are true. But I'm just going to take the easy way out and say they're true. So, but what I'm doing on the board is I'm saying, now, wait a minute, this is one identity, but it's hiding two others. Because you could also say that I could move sine squared over, and I could say cosine squared equals 1 minus sine squared theta. Or I could have moved the cosine over, and I'd have sine squared equals 1 minus cosine squared theta. So understand that every identity slash true equation, which is an equation in sentence, actually, this is going to be awkward, gives birth to two others. So that one is actually 3. Same thing here. I could actually say that tangent squared theta equals secant squared theta minus 1. Just subtract 1 from both sides. Or I could say that if I wanted to, I could say that secant, secant squared minus 1. I think we're just going to stop right there and call her good, okay? So the rest of it's going to get kind of weird. So this one, I could also say that cotangent squared theta equals cosecant squared theta minus 1. So you got to be looking out for this. You got to be also looking out for this. You got to be looking out for this and looking out for that and that and that and that. Well, what do you mean be looking out for it? That would come when we do our packet lesson. So this is just warm up. Now you got a whole bunch of reciprocal identities. You've been taught that cosecant is the reciprocal of sine. This is just a different way of saying it. You've been taught that secant is the reciprocal of cosine. This is just a different way of saying it. Now, interestingly, tangent is equal to sine over cosine. This is something you should get to know quite well. You should also know this, and you should also know this. Now, this is just saying that sine is the reciprocal of cosecant. This is saying cosine is the reciprocal of secant. So you really should know these relatively well. What I'm saying is, how many identities do you see here? 6. What if I went like this? Now you have 12, okay? So you have to be on the hunt for the ones without all the squareds, and you have to be on the hunt with all the ones with the squareds. Now be careful. If you look at this, this is not saying to ever square that angle. Think about that. If this is sine of 30 degrees and I squared that 30, it'd be sine of 900. That is not what that is saying, but that's for a future question, a future moment. There's your pre-lesson. I know it's a little spotty, but it kind of gets the job done. This is a very, very unique section.